Service class. It is another edition on service class, and we are so excited to have you. We are working assiduously to bring you the best and the best. So we plead when we have, maybe you might be expecting videos from time to time, but sometimes you see there are intervals in it. We plead with that. We are always working to give you the best and the best. Yes. Today we are going to look at BECE in focus, as we are still on, and we'll look at integrated science practicals. We'd like to try our hands on some practicals. And practical is also essential when it comes to integrated science. The integrated science is grouped into two sections. We have part A, section A and section B. Under the section B, we have part A and part B, or part 1 and 2. Part 1 is where we give students some practicals, about 4 of them, each of them containing 10 marks, so in total 40. And we have the written, the optional part where students have to choose 4, and then totaling marks of 60. So 60 added to 40 practicals gives 100, and then the objective 40 added to the 100 gives 140. So whatever you get will be striped. We divide it by 140, we multiply it by 100. That is how social studies is marked, standardized marking and then grading for it. So we'd like to take some practicals and then try our hands on them and see how far we are doing as far as science is concerned in the BECE 2023. And also our time is very closer, very closer. So we urge our learners to study. Whatever we post, you take them serious. You also read more, and then we help ourselves. Okay. So the first one, and the questions will be displayed on the screen. So let's continue. So the first question says, the funnels in the diagram below contain equal amounts of different types of soil labeled K, L, and M. Equal volumes of water were poured onto each soil at the same time and allowed to drain for 20 minutes. Study the diagram and answer the questions that follow. So in the diagram we have 3 soil samples, that are the 3 types of soils, that is the sandy, loamy, and the clayey soil. Each of them in a measuring cylinder with funnel, also with water. The first one, called soil K, has a funnel in it with a sample of it with water draining. The second one, soil L, also with a funnel with a sample of the soil with some water draining. And soil M with a cotton wool with a measuring cylinder, a funnel, and some water draining out of it. The first question says, what is the aim of the experiment? Now, whenever you meet a question of this sort and you are asked, what is the aim of the experiment? They are trying to ask you, why has this experiment been conducted? We all know when we talk of science, science is the method where we obtain knowledge through observing and experimenting. So after observing and after reading the question, what is the aim? What are they trying to find or identify? Now, the best answer to give to this question is an experiment to demonstrate the water holding capacity of the 3 soil samples, or an experiment to demonstrate the drainage feature of the 3 soil samples. So that is question number 1, AI. Yes, so I has been answered. That is to demonstrate the water holding capacity or the drainage features of the three soil samples. II. Which soil has the highest rate of drainage? Which soil has the highest rate of drainage? So here, look at the setup below. Which of them has the highest rate of drainage? We are simply talking about which of them. In which of them can you identify that the water drains so quickly? So quickly. And I think we can identify that in soil K. Soil K. Why is it soil K? It is soil K because when you look at the water that is found in the emerging cylinder, it has quite a higher volume compared to the other ones. So it means that with that, the water drains faster. The water is released so faster. So the answer to II is soil K. Soil K. And then when we're looking at nature of soil in Form 1, we're all told that the soil type that has the highest water drainage, or the soil type where water drains so easily or fast, is the sandy soil. So you can also be specific here. Soil K or sandy soil. Soil K or sandy soil. I. Which soil has the highest water retention capacity? So here the question is trying to talk about which of the soil types is able to retain or hold water. Now we can do this by verifying from the samples over there. Now look at soil K, L, and M. Which of them is holding the water? Actually retains it. That is soil M. Because look at the amount of water in the measuring cylinder. It means that it is not draining fast. It still holds the water. So the answer to I is soil M. Soil M. Soil M. Also in our studies, we learned that the water that has the highest water retention capacity is clayey soil. So soil M or clayey soil. IV. Which soil is most likely to lose water and dry faster after rainfall? So which of them is most likely to lose water completely and also become so dry right after rainfall? Now let's look at the soil samples. We can do that by identifying the one which has the highest water drainage or water drains so fast. That goes to soil K, that is the sandy soil. V. Which soil is most likely to be waterlogged after rainfall? Which soil is most likely to be waterlogged after rainfall? So they are trying to ask us which of these soil samples would there be a waterlogged condition found in this particular soil type. Now when we say waterlogged, we are trying to talk of the soil type where when there is rainfall, when there is water on it, though it is going to drain quickly, but the nature of it, how soft and finer it is, that place will look like still there is water on it. Yes, the place looks soft, there is still water beneath. Okay, so let's look at which type of them that goes to clay soil, or soil, the soil M, the soil M, the soil M. Then VI. Which of the soil types would be suitable for maize cultivation? We are talking of the soil type that is good or recommended for agriculture. And that goes to the soil L, that is loamy soil, soil L, and that is loamy soil. So, so far so soon, we are done with answers on 1A. That is an experiment to demonstrate the water holding capacity of the terrace soil samples, or to determine the water drainage. Let's move to B. Terrace B. Now, the diagram below illustrates hazard symbols labeled I, and I. Study the diagram carefully and answer the questions that follow. So we have I, and IV. So what does each of the symbols labeled I, and IV represent? So this reminds us of hazard, anything that causes danger to one's health. So the I is mostly seen on things that are so poisonous or toxic to the body. So any hazard that looks that way is called toxic, toxic or poisonous. So anything that has a symbol simply means that it is toxic or poisonous. I, that is corrosive, anything that burns. Corrosive, corrosive. I. And we have highly inflammable. Highly inflammable. Others also call it flammable. Highly inflammable or flammable. Then IV. IV. We have no smoking. We have no smoking. No smoking. No smoking. Or in other words, naked fire. Naked fire. Naked fire. II. Name one substance each that is associated with alpha I, beta II, and gamma III. So say we should name one substance, anything, any chemical or any other substance that has any of these symbols, that is I, and III. So on what can we identify this symbol on? So alpha, toxic. Toxic. On what substance can we find things that are toxic? Now there's what we call cyanide. It's toxic or poisonous. Mercury. When you go to the mining sites, these chemicals are so popular over there. Cyanide, mercury, crude oil is poisonous, and hydrogen peroxide. Hydrogen peroxide, and then you can also add one more to it. That's some of the gases that we inhale from cars, fumes, carbon monoxide. Carbon monoxide, and the like, and the like. Beta, corrosive, things that are corrosive, things that burn. So we have hydrochloric acid, we have nitric acid, we have sodium hydroxide, that is a BECE, sodium hydroxide. We also have potassium hydroxide, they are also part. And the last one is highly inflammable, things that we can identify these things on. So petrol, diesel, diesel, and then sometimes we can identify them on liquid nail polish, liquid nail polish, liquid nail polish, liquefied petroleum gases, and the like, and the like. Now the next question talks about name the place where the symbol IV is often displayed. So IV, that is no smoking, where or some of the places where it is easily seen. Now, places such as fuel stations, and identify this no smoking there, bar stations, shopping malls, and the like, and the like. Sometimes in schools, hospitals, and the like. Why? We have to not to smoke because there might be a naked flame that is moving around, or a naked gas or a harmful gas. And if care is not taken, it catches fire, and that is all. It causes destruction. And then Ivy, which of so we are on Ivy. Yes. So this one was I. Yeah. No, this one was I. So we are on I. So first question we're asked to identify them. Second, we're asked to name substances that are associated with them. So we start from here, I. Then thirdly, we're asked to name a place where you can identify IV. So here, that for I. Then IV, which of the symbols is or are found on chemical containers? So which of these symbols are found on chemical containers? Now I, mostly I. You find I on chemical containers. That is toxic. Sometimes things that are chemical, they are seen as poisonous. So sometimes you see this thing on it, toxic, meaning to deframe you or to resist you from touching or using them. Not also toxic. Now also sometimes corrosives, things that burns, acid, you see the symbol there, and then you can also see highly inflammable. So containers, here it's talking about containers. But the third question was talking about places where we can identify the symbol called no smoking. That was places, I. But I is talking about some containers where we can identify any of these chemicals, any of these symbols, any of these symbols. Now the last question under B says, which of the symbols, okay, we've done that, that is Ivan. That is Ivan. Which of the symbols is illustrated or is found on chemical containers? Good. Now let's go to C. C. Now C is a question on machines. The diagrams below are illustrations of devices used to do work easily. Study the diagrams and answer the questions that follow. So we have A, B, C, and D. I, give a general name for the devices. A general name for the devices. This is under machines. And you know we have two types of machines, simple and complex. These things are used to do work, simple work. So we have them as simple machines. So I, simple machines. I, we have simple machines. I. Identify each of the devices labeled A, B, C, and D. So A is wheelbarrow. We all know this popularly. Wheelbarrow. Yeah, together. Wheelbarrow. B. We have inclined plane. Inclined plane. C. We have what we call a, a pulley. A pulley. Pulley. That is Pulley. Pulley. And D. We have what we call the gear. The gear. The gear. Okay, so let's move on to the next question. Now, name the parts labeled I, and I of the device A when it is considered as a lever. So they said the parts I, and I of A. What is A? A wheelbarrow. So they said the parts labeled I, and I of the wheelbarrow. Let us identify those parts. That is question I. So let's look at comparing it to simple machines. When we say simple machines, that is a tool or machines that has a fixed or a rigid bar that turns freely about a fixed point, and then it has some force acting on it, and the force is applied on a particular load or on a particular work. Good. So any machine that has what we call the pivot, effort, and the load. So I will be the effort. That is where the force will be applied. Effort. I will be the load. That is where the things will be placed into the load. The load. And I will be a pivot. Pivot or fulcrum. Pivot or fulcrum, the center or the turning point of the machine, the pivot or fulcrum. So we have effort, we have load, and pivot or fulcrum. The next question, Ivy, what does the arrow represent in the device labeled B? So there's an arrow where there's a man pushing a tank or a barrel up on a plane. So what is the direction? What is the meaning of the arrow? The arrow is talking about a force that is causing that container to be pushed upwards. Now the force applied at one end of the machine is the effort. So the answer to that question is effort. So I win is effort. Effort. Now V. Name the type of work done with each of the devices labeled C and D. The type of work done. So C and D. So pulley. That is alpha. Now what do we use pulley for? What do we use pulley for? Now mostly we use pulley for lifting things, heavy things, for lifting heavy things, heavy loads, either lifting them or to lower them. So for lifting or lowering loads or items. Then C and D, gear. The gear. Now you can see the gear aids in movement. The gear aids in movement. It is also used to change the speed or direction. For moving movement or changes the speed or direction of a body. Believe you are following. Okay, so now move on to D. D. Okay. So D. The diagram below illustrates the digestive system in humans. Study the diagram carefully and answer the questions that follow. So we have the digestive system of a human being. Name each of the parts labeled I, I, IV, and V. So D, the last particle, and the last is the last particle under the head. Okay, so the parts I to V. So I. Now look at the I. Digestive system is a system that talks about the intake of food, that the ingestion of food, how food is digested to release energy. So I, now where the arrow is pointing is, I will be the stomach. It simply means that our stomach, you can't see them. So most people say my stomach. Sometimes it might be your belly. The side is your belly. The stomach is deposited inside of it. Stomach. Then I. We have what we call, so look at where the arrow is pointing pointing to small intestine. Sometimes we call it the ileum. I. We have what we call the large intestine or colon. Large intestine or colon. IV. We have what we call the rectum. That is where the undigested part or the waste of the food, the waste part, the waste food that is kept before the anus finally releases it. The last one is the esophagus. Or in other words, gullet. Or in other words, the food pipe. So it is the passage for food. Okay. So we are done with I. Now I. Name the parts of the digestive system where alpha, digestion of food substances, occur. So, in which part of the digestive system does digestion of food start? The mouth is one. So mouth. Aside the mouth, so we know starch or carbohydrate digestion starts in the mouth. Now we have stomach. Protein digestion goes on there. We have small intestine. Some digestion also goes on there. Small intestine. Okay, small intestine. So the mouth, stomach, small intestine. Sometimes with the duodenum, there's also digestion going on. Beta. So beta. Name the part of the digestive system where digested food is absorbed into the bloodstream. So where is digested part of the food absorbed into the bloodstream? Because we all know that digested food, the nutrients derived from it go straight into the bloodstream. So it goes somewhere before it is taken to the bloodstream, and that is the small intestine or the ileum. small intestine, or ileum, small intestine, or ileum. I. Name the end product of the digestion that is absorbed into the bloodstream. Name the end products of the digestion that is absorbed into the bloodstream. So the end product of digestion. Now we know carbohydrate will give us glucose. We know protein will give us amino acid. We also know that fat and oil will give us fatty acids and glycerol. Fatty acids and glycerol, the end product of digestion. And this is where we bring an end to the practical. So we are going through some practicals, and then we believe you are following. We've come to, not that we are done with everything, we've come to the end of the first part of it. So we'd like to take some different practicals and also try our hands on them. So at this moment, we'd like to take a short break, and then when we are back, we'll continue with the next thing that we have for you. It's a Henry's class. So welcome back from the commercial break. I believe you've taken some water, you've quenched your thirst. Now, let's continue. So the next practical. The diagram below represents the stages in the life cycle of a mosquito. Now study the diagrams carefully and answer the questions that follow. So I says we should name each of the stages labeled I, I, and IV. The life cycle of a mosquito. Now, I is the X. We all know that. Yes, I is the X. The X. So we'll say raft of X. Raft of X. Or if you say X, we'll give it to you. I is lava. Lava. I is the pupa. The pupa. IV is the adult mosquito. Adult mosquito. Adult mosquito. Okay. II. State how state 2 obtains oxygen. Now what is state 2? That is the larva. How the larva obtains oxygen. How the larva obtains oxygen. Now at that stage, the larva has what we call the tube, the breathing tube, and those are what the larva uses for breathing whilst it is beneath water or whilst it is underwater. So you see it uses the breathing tubes. It uses the breathing tubes. I. State 2 methods of controlling each of the stages labeled I and IV. So methods of controlling I, and IV. So how can we control I? That is the pupa stage. How can we control it at that stage? Now, what we can do is by introducing insect eating fishes. Insect eating fishes, that is fishes that feed on fishes, an animal that eats on fishes or feed on fishes. We can also say applying oil or kerosene. Applying kerosene to reduce surface tension. Applying kerosene to reduce surface tension. So aside that, what else? We can also talk about the draining of the stagnant water. We need to drain it. Draining of water, draining of stagnant water. Make sure we clear that water, we drain it. Yes, so draining of stagnant water. Now let's go to IV, the outdoors. How can we control it? You can control it by the use of insecticides. The use of mosquito coils is also not left out. We can also use spray or the insecticides. Yes. And then we can also sleep under treated mosquito net. Yes, so nets, mosquito nets, and the like. Also talk about clearing weeds and the like. Now let's go to the next question. B. The diagrams below are different laboratory setups used in the separation of mixture. State the diagram carefully and answer the questions that follow. So A, B, and C. So I, name each of the parts labeled I, V, and VR. So that is B. Now let's look at I. What is I? I is a beaker. Now what is II? II is an evaporating dish. Now what is III? III is a Bunsen burner. IV. IV is a funnel, an inverted funnel. V. V is the tripod stand or tripod stand. Good. So these are the names of the tools and apparatus that we have there. Now the next question says, name the separation method represented by each. So what method of separating mixture is illustrated there? Now A. What is A? A is a method of separating mixture that involves some insoluble solids and liquid. Good. So there's a solution. You want to separate the insoluble ones from the soluble ones, or want to separate a solid from a solvent. So A is a mixture of muddy water, and that is filtration. B, we have heat, we have an evaporating dish. So basically there is evaporation. That is the clue, evaporation. C. Now what is C? So C is sublimation. Method where solid changes directly to gas by the use of heat. That is sublimation. Okay. I. Which of the setups is used to obtain clear water from muddy water? I think we just said it. That is setup A. Or you can also be specific filtration, filtration. I says which of the, okay, we did I, yes. So we did I. So here's I, okay. So I is I and IV. So IV. Which of the setups is used to obtain salt from salt solution? Salt from salt solution. And that will go to setup B, that is evaporation. Now, social studies will tell you method of deriving some minerals, that is salt, is from evaporation method. Evaporation method. Here, salty water is collected, it is left for evaporation to occur, and the water or the liquid changes to gas, leaving the crystals. Good. Okay, so we are done for that. Now see, the diagram below shows some instruments used in the laboratory. Study the diagrams carefully and answer the questions that follow. That follow. This one is still on the B. So C. Okay. So I, and IV. So I, what instrument is that? The tape measure. Tape measure. I, what instrument is that? That is the stop clock. Stop clock. Someone can also say clock. I. That is the thermometer. Thermometer. IV. IV is a weighing scale. A weighing scale. A weighing scale or the weighing balance. The weighing scale or weighing balance. Okay. Then move on to the next question. That is II. So this II. State one use of each of the instruments labeled III, and IV. The use of each of them. Now I is tape measure, and we use it to measure length. Length. II is a stop clock, and we use it to measure time. So I for measuring temperature, for measuring thermometer, for measuring temperature. IV, that is weighing scale or weighing balance for measuring mass. Yes, for measuring mass. For measuring mass, yes. So I for measuring the length, that's tape measure for measuring the length. II for time, II for temperature, IV for mass or weight. You read and record the volume of the liquid in the instrument's labeled vein. You read and record the volume of the liquid in the instrument vein. Now the vein is a measuring cylinder. So the volume of the water in it is 160 centimeter cube. 0.60 centimeter cube. So that brings us to the end of the C. Let's go to the D. The diagram below shows the digestive system of a class of farm animals. Now study the diagram carefully and answer the questions that follow. So I is the esophagus. So that is D. I. So I is the esophagus. And this one is the digestive system of farm animal, that is ruminants, that is the animals with the 4-chamber stomach, or animals that chew the cud or grass. Now I is the gizzard. I is the gizzard. I is the liver, and IV is the crop. Okay. So I. State one function each of the parts labeled II and IV. So function of II and IV. So we are looking at the function of the gizzard and the crop. So the function of the gizzard. Now the gizzard grinds or crushes food. It grinds or crushes food. And the crop stores food temporarily. Stores food temporarily. Now I. Name 2 farm animals that possess this type of digestive system. So animals that have this digestive system, as I said, the ruminants. So you can have sheep, you can have goats, you can have horse, you can have cow, donkey, and like. Mention 2 diseases that affect this class of farm animals. Diseases that affect this class of farm animals. So some diseases that can affect these animals. We have what we call the coccidiosis. We have what we call the Newcastle. We have what we call pneumonia. Pneumonia can affect farm animals. Okay. We also have what we call some bird flu. Yes, bird flu, trypanosomiasis, and the like. Bird flu, diarrhea, bacillary diarrhea, some goat pox. These are all some of the diseases that can affect these farm animals. Listed below: turkey, guinea fowl, and the rest. So this brings us to the end of the practical session. Now, this will end, and then we'd like to introduce more of them. So we wouldn't end here. We will not say that is all. We would like to be posting most of them, so that when it comes, we'll be able to write something and then come out and excel. So this will end for today's session. We'll continue some other day, some other time. This is Henry's class. If you've not subscribed, make sure you do so. Hit on the notification bell, share, like, comment. Thank you for having time and watching us. Bye.